everybody, and welcome back. This is going to be part 2 in our series of upgrading the TRS-80 Model 2. The first video consisted of me putting in an upgraded power supply so that the Model 2 could handle more than 5 boards. If you're interested, I recommend going back and watching that. But today's video is going to be the visual upgrade. Today we're going to be putting in the Model 2 HiRes graphics card. Now, if you're familiar with the upgrade to the Model 4 or even the color computer itself, the new graphics command shown should seem familiar. It gives you the ability to draw circles, draw lines, paint inside of shapes, and address individual pixels in graphics memory. All of this for the low price of $4.99 in 1981. Today, that's over $1,700. Not a cheap upgrade back then. Now, before I start working on it, let's take a look at the card itself. On the left is the memory chips. It uses 16 4116s to give the card 32K in memory. And near the top is 2 ribbon connectors and 2 empty sockets. Now, this card doesn't replace the keyboard video driver card that's installed, but it's an addition to, and they work together. That's why the empty sockets. I'll need to transfer the display driver chip to the 40-pin socket and the character ROM chip to the 24-pin socket. Then I'll have to make 2 ribbon cables to go from the now empty sockets on the existing video card to the ribbon connectors at the top of this board. Now, when it was new, this card came with those ribbon cables, but of course it's not new. I got it from eBay. I have no idea if it's working, and it didn't come with the cables, so let's take a look at it. Now, here's the graphics card I got. As you'll notice, it pretty much looks identical to the photo we were just looking at. And here's my existing keyboard video card. Notice the 2 chips at the top will be transferring. Now, these 2 cards have to go side by side in the card cage in the back so that the ribbon cables can be as short as possible. Then we'll take the existing character ROM chip, put it there, the display driver chip, put it over there, then get a ribbon cable with a standard ribbon cable end, take them over to here and connect them with a ribbon cable dip socket connector. And here are the 2 cables I got. Here's the 40-pin. I got them complete with ends on them, so that way all I have to do is cut them in half. Here's my 24-pin. That way all I have to do is cut them in half, and half the work of making the cable itself is complete. All I'll have to do is put the dip socket pins on the other end. Okay, first I'll plug this into here, since this side's already complete. It's one thing I don't have to worry about. Really, all I have to worry about is the other side. Let's see. Be approximately like this. Notice I have to give it some extra space because the socket that it goes to is a little further north. So I'll have to do something like this. Okay. Give it just a hair extra length, but not too much. That's actually pretty darn straight. Okay. I've got it in. I got the top set. What I need to do, see, I can't put it in the vise like you've normally seen me make a cable because I'll crush the pins. Okay, so I found what I'm going to use. It's a bit holder. It's hard plastic, and it just fits between the pins. Now I can put it in the vise and it won't crush the pins. So let's see how that works. Okay, that seemed to work quite well. Pinched it down, didn't tear anything up. Pins aren't smashed. Well seated. Well, I just got to do the other one and then we can take a shot at this. Okay, I measured them. I cut it about here. Still fits perfectly, of course. And let me go crush it. Okay, we got it. Seems to be sealed pretty well. The lines are matched up. So let's put it in. First, we have to move these two chips to the new board. There we go. No bent pins. Now, you got to pay attention because on this board, this one is facing this direction. It says pin 1 up here. So this one gets turned around, so you got to pay attention to that. Just got to be slow and careful, that's all. This chip goes on the same way it did on the original board. Nice and snug. No bent pins. Check the pins on both sides before I snap. There we go. Looks good. Okay. And get the original board. It'll get in its place. Yeah, do it this way. This goes here. Plenty long enough this time. Okay, now make sure the boards are back into place, right? All jostling around. Now, the first thing to make sure that it works is see if I've got a regular screen. Since the chips have been transferred to this, that will at least prove that these cables are correct, and at least most of this is working. Okay, it's plugged in. Let's see if we get a decent picture. And for some reason, it's reversed. We definitely got a problem. All right, let's see what's going on. Well, I think I found the problem. When I put this chip in, I bent one of the pins. It looked perfect, but I pulled it out to recheck and it was completely bent under. So let's see how it does now. It did not work. At this point, I realized the mistake I made. In this part of the video, you'll see that I realized that I made the cable basically backwards, putting the character ROM in a way that it was like it was in the socket backwards. What I didn't realize at this point was the ROM is destroyed. And I didn't record all the different times that I kept trying till I realized that it was. Also didn't record the fact of me cussing and trying to find a replacement ROM, and I got real lucky to find a replacement for that character ROM. So after this part of the video, you'll see the thing boot up properly. That's after I put in the new ROM. Please don't make the mistake that I did. If you power it up with that chip in backwards just once, it'll be gone. So the actual time to the next clip is actually about 2 to 3 weeks. Okay, let's see what happens now. There we go. We can test it with the diagnostic disc, 6 video test, 1 HiRes. Oh boy, that ain't right. But I tell you what, right off the bat, that is going to be memory problems on the graphics board. There's going to be a problem with, here we go. This is the test results. Possibly defective chip U09. Yep, U09 right down here. It's a DRAM chip for the memory. Let me see what the number is. 8041016. Let me look that up. I can't remember off the top of my head. So that is a Radio Shack number for a 4116. Just as simple as taking out this chip, putting in our replacement. Well, that didn't help any. Oh, look now. Now it doesn't say 9, now it says 10. All right, I changed U10. Same shit. It still says U10. I think I'm getting a little punchy. I didn't replace U10 the last time. I replaced U1 by accident. So, put the other one back in. I replaced number 10. Here we go. Now it says U12. I've got a memory checker here. I don't think it'll check 4116s, but I'm going to double check and make sure. All right. I've received a nice new batch of 4116s, and we're going to replace all the video memory on the graphics card. Well, that's interesting. I've got the whole bottom half working perfectly, but the top half still isn't. Well, right now it's saying U4's got a problem. Who knows? Because you saw what it did last time. It just constantly likes to point to another chip. Okay, I replaced U4. I bought 24 chips, only needed 16, just in case this would happen. HiRes. Hey, look at that. Now that's a lot better. I can actually read the whole thing. That doesn't mean the whole thing's going to work, but that's definitely an improvement. Let's see what we get. Still good. I saw those earlier. This is still, that's still some sort of error. There shouldn't be underlines randomly in that row. A lot of this looks so much better though. See, those shouldn't be showing up. That sure is a lot better. Okay. This is checkerboard pattern, but that's solid gray. That, I don't know if that's what that's supposed to look like or not. I have a funny feeling no. Hey, it's never even ran this before. Must have had so many bad chips it wouldn't even get this far. That's pretty cool. I don't know if it's supposed to look like that. Hey, that's neat. See the dashes though? They're always there in all these tests. Oh, let's go into another test. Ah, we must have, oh, wow. That's nice. Still, those dashes. Yeah, look at that. It's saying it thinks, holy cow, at least U1 and U9.
2,000 years later.
Okay, I got this new ESR meter. And I'm going to check the capacitors here first. And see, it comes up 0.3, and that shows up as good. Let's see this one, and that shows up as good. I'm going to do this one next. Let's see where the negative is. That would be here. Oh, come on. 0.4. That's... Hey, that is not what that's supposed to read. It looks okay. Let me try it again. Yeah, that is definitely not what it's supposed to read. Okay, there is something promising. Notice it's on memory test pass 34, and there's yet to have any errors whatsoever. This is a first. The best I'd had before was, I think it was like, what was it, 47 passes and 6 or 9 errors, something like that. I can't remember. But this is the first time I've ever had this many passes and 0 errors. This looks promising. Let's take a look and see what the graphics card disk will do. All right, time to actually try this out. Looks like everything should work. This is a copy of the disk that actually came with the board. I downloaded the file, made an 8-inch disk. See what happens. I have read the instructions for this disk, so I tried to look up a little bit so that once we get it going, we can right away try a couple of things and see how they look. Came up well. You're actually looking at 2 screens at the same time when you turn on graphics. Watch, I'll turn on the graphics screen. That looks like an error. It's not. It's the graphics screen overlaid, but it has garbage in it. Let's clear the screen. GCLS. And there you go. You're actually looking at a text screen and a graphics screen at the same time. And I'll show you how, if I can load this properly. Let's see. Let's see. And there we are. Now, I'll show you that you can clear the text screen so you can see it better. See? It's interesting. I've never seen this before. That way you could write programs where you had graphics and text easily, and they don't interfere. As a matter of fact, you can put text across this picture, and then you can delete it, and the picture is undamaged, which is a little different than some graphics on other computers that the text would damage the graphics and it would have to be redrawn. It doesn't here. See? You're seeing them both at the same time. Let's see. All the ones that end in GRA are already written basic programs. So, okay, let's try something else. Basic G is the version of Basic that allows you to use all these graphics, these new graphic terms: circle, line, put, get, set. Now remember, this is a Model 2. This is a business computer, so a lot of the examples that are on here look to be like pie charts, bar graphs, business associated. It's not bad. Looks like a PowerPoint to sleep by to me. Boy, I hope that ain't it. Here we go. It's not the right time, but it is the current running time on the system since I didn't set the time. Well, hey, stuff that it couldn't do before. Next time, we are going to convert the Model 2 into a Model 16. The Model 2 had a Model 16 upgrade expansion, and we're going to tackle that next. Hope you'll be with me. See you next time.